Hi, Yana. I apologize for taking so long to get back to you. We had trouble with the website yesterday and I couldn't upload the assignment and make the video for you, unfortunately. So I'm going to look at Unit 2, Topic 5, first of all, and I think that you had indicated that you could do the first one. So with the second one, what they're asking for in the second question is that you talk about the displacement of the particle, and the displacement is s, okay? The only time that the displacement and the distance traveled will be different is if it reverses direction and goes back towards the way it came. Then your displacement will be less, but your distance traveled will be more, if that makes any sense. So I'll show you an example of what I'm talking about with number 2 and number 3. All we need to do here is pick values of t between 0 and 4. So at t equals 0, the displacement is going to be 27 because 0 is 0 plus 27. And 27's roughly, this is a little bit hard to do here because it's not in that scale, but it's just a little bit over the 20. Don't see, oh, there we go. Okay, put a mark there. Now, if t is equal to 1, all you have to do is fill in 1 squared plus 6 times 1 plus 27 and so on. And then we're going to end up there with 32, I believe. Okay, so then for t equals 1, we would go up slightly to 32 and so on the graph. Oh, it's not lining up, I'm sorry. It's just because my stylus is not really pointed. So all you're going to do there is just keep filling in values. So the next value is going to be minus 2 squared plus 6 times 2 plus 27 and so on. And if you graph those and they're all going away from the origin, then your displacement and your distance are exactly the same. So you would do the same thing for number 3. For number 3, it's just asking you to fill in values for t between 3 and 8. So I would kind of do it as a table of values where you have t and you have s, and you're going to fill in t equals 3, and you're going to put that into the equation and work out the values for t and so on and graph those, okay? So that's all that's required in number 2. You're just working out displacement. There's no derivatives involved. For number 4, the question is asking you to find speed, which is velocity, at times t and when the speed occurs over the given interval. So what we're actually being asked to find is velocity, which is the derivative of the displacement equation. And so what you want to do first is find the derivative s of t, s prime of t, sorry, which is equal to v of t. And in the first case, it would be negative 3t squared plus 36t minus 81. And you're going to fill in values between 2 and 7, so maybe a chart again, t and v here for 2, 3, 4, 5, 6, 7, and so on, and work out what v would be. And here they want you to do a graph for the displacement, so you would have a chart with t and s, and for the velocity, which would be this chart. And you're going to put those two graphs, those two sets of points on the grid, and they want you to compare them, I think, okay? Now, for number 5, it's talking about the displacement function again, and they've given you the displacement function s of t. They're asking you for v of t, which is the first derivative, and a of t, which is the second derivative. And so if you start with s prime of t, that's v. And if you take the double derivative s double prime, or even v prime, then that equals a, okay? And so again, just do a table of values for the interval. Just looking for the interval here, it's for t greater than 0. and they want you to find when it's changing directions, okay? So with changing directions, what you want to do is you want to take v of t, your velocity, and you want to set it equal to 0 because the speed for an instant is going to be 0 if it was going in one direction and then turning around and coming back the other direction. We call that a turning point. And so we're looking at something traveling like this and then all of a sudden abruptly turning around and starting to travel that way instead. And at some point the velocity has to be 0 when that happens. So if you set v at t, this one's v at t, equal to 0, you'll find those turning points, and that's when the particle is changing directions. Okay? Oh dear. All right. So for the last couple of pages there, that's the same assignment, but it's giving you the answers to check over. And so when you've got a chance to try those answers and your derivatives and things, then you can compare those to the graphs that they give you for the answers and make sure that you understand it correctly. And if there's something that you can't get to match the answers, why don't you send me a screenshot of your work or a scan of your work, and I will check it over and see where you went wrong and email you back. And that's a good way for us to learn as well as to identify where we're going wrong. And then I can teach you a little bit more about that particular part of the solution, okay? All right, so I hope that helps, and then email me back and tell me what else you need to go from here, but this is a good first step.